Okay, so what we're going to do today is we're going to take a look at a set of data that is displaying two different variables. We're going to look at one of the variables being categorical, that being the method of travel, and one of the variables being quantitative, which is going to be the time of travel. To give this data some context, what we're looking at is 35 different individuals, and those individuals are North Carolina high school students. And so this is basically their responses to the questions of what's the primary way that you, method of transportation that you get to school with, and also what's the time it takes you to travel to school. So for this video, what we're going to focus on is the categorical data, because what we're interested in initially, and something that you've already looked at in the classroom, is how can we start to make inferences from a small sample, so this being 35 students, to a larger population. So for example, from this, the population of high school students in North Carolina. So to be able to do that, let's first look at what we actually have in this sample with the data. And so if we look at this, we're going to look at this in terms of a bar graph. And we can look at essentially two different summary statistics for this. One being the frequency, or how many individuals were in each of the categories. So the number I'm pointing at now, 18, tells us that there are 18 individuals out of our 35 that reported using the bus to get to school. And we also have relative frequencies, which here are presented as percents. And so 51%, or 18 divided by 35, of the students in this sample reported riding the bus. So based on this data, we can start to see some patterns just from the sample. So clearly from this sample, the bus was the main method of transportation for students, followed by the car and walk, which were relatively equal to one another in terms of 26% and 23%. So what we want to start to do, though, is we want to start to talk about this is what happened in this particular sample. But we know that just by chance, we're going to see differences from sample to sample. And so to begin to make estimates towards a population as to what might be an estimate of the proportion of North Carolina high school students that ride the bus, what we need to do is we need to look at the idea of, well, what type of variability are we likely to see from sample to sample to do that? And so what we do for this is we create what's called a sampling distribution. So essentially what we're going to do is we're going to use this sample as a population. And then what we're going to do is we're going to randomly draw samples from that population. And so in this software, what I'm going to be doing is I'm going to be telling it to start, it's going to take 10 of the individuals at random, and it's going to collect 25 different samples. So what I'm going to see in a minute is 25 samples, each of which drew 10 students at random. And so we can start off kind of slow here. We're seeing car, walk, bus, walk, bus, bus, car, bus. That's one sample of 10 items. Now it's going to end up doing this 25 times, so clearly we're going to speed up a little bit because this could take quite a while. So what you're seeing in this table now is you're seeing one single run of this experiment. Within this experiment we have 25 samples. Each of these samples represents 10 items, or 250 items total. So what we're interested in is we want to look at what proportion of each of these samples had people reporting riding the bus. So to do that, we have to create a sample statistic within the sample. And so we're looking at a proportion, so we're just going to label this as the sample proportion. So then for it to actually do the calculation we want, we have to tell it how we want it to calculate this. And so we have to create a formula. So what we're doing is we basically want to add up all of the instances that reported bus, and then we want to divide it by how many values that we have within the sample. And so that's going to give us our sample proportion. And so to do that, we're doing a sum. But we only want to sum things that are referring to bus. And so what we're referring to is the method of travel. And we want that method of travel to be equivalent to bus. And so then what we're going to do is we're going to refer to anything that's bus as 1, anything else is 0, and then that will give us our count that we're looking for. Now remember, we still need to divide this by how many values we have total, and remember we have 10 items in each of these. And so if we apply this, we'll now see what proportion of each of our 25 samples consisted of people that reported riding the bus. So we're seeing these as individual sample statistics, but what would be a little more helpful for us is to see this as actually a distribution. And so what I've just created here is what's referred to as a sampling distribution. So what you're seeing is each of these points represents a sample proportion. So the one I'm highlighting right now is a sample proportion of 0.2, which means that one of our 25 samples had 20% of the 10 individuals reporting that they rode the bus. Now if you remember, if we go back to the original sample up here, in our original sample we had about 51% of people reporting that they rode the bus. And so if we look at our distribution down here and we look at the center of that distribution, you'll notice we're relatively close to that value of 51 when we look at these. We can also see that in terms of our median measure of center, which is actually down here at 0.4, and we can look at our standard deviation or our spread. Now notice I couldn't have looked at any of these measures in our original distribution because what we were looking at originally was a distribution of a categorical variable where the only summary statistics we can look at are frequencies and relative frequencies. Now what we're looking at in this sampling distribution is we're looking at what's basically become a quantitative variable which represents the sample proportions for each of these 25 samples. And so up here in the original distribution, a single point represents a single individual and their answer to the question of what their main method of travel to school was, versus in my sampling distribution, a single point represents the proportion of 10 individuals that reported riding the bus. And so we can now look at this from a quantitative perspective. Notice too, we can also start to talk about what's the shape of this distribution. So we're starting to see a relatively symmetric distribution with the center around what our original proportion was. Now we want to start to use this though to go back to that original question that we had of we're trying to figure out an estimate for what's the proportion of all North Carolina State high school students that ride the bus based on our smaller sample that we're assuming is representative of the larger population. And so to do that, what we end up with for an estimate in this case is not a single value, but an interval of values. And the most common interval that we use is what's referred to as a 95% confidence interval. So to be able to construct that 95% confidence interval, we have 25 different points here. So basically what we want to do is we want to come up with an interval that's about the same distance from the center to the left and the right that includes all but one of the points, which would give us 24 out of 25, which is 96%, so close to 95. And so if we look at where our distribution is here, and we look at this visually, and the center is about 0.5. If we go 0.2 to the left and 0.2 to the right, then what we're going to contain is all but this one value down here, this minimum value. And so that would give us 24 of our 25 values. And so the way that we can describe this is we can describe now that based on our sampling distribution, we're about 95% confident that the interval, that the true population proportion, so in this case, the true proportion of North Carolina high school students that ride the bus is somewhere between 0.3 and 0.7.